Good morning to everyone. Welcome to Viswa Vidyalayam Iit-Jee classes. So myself Anil Kumar. Today I will tell you about sets theory, which is a very important topic in the Iit-Jee. Okay, students. So first, let me explain you the basic concepts in sets theory. The definition of set. What is a set? Set is a collection of well-defined objects. Set is a collection of well-defined objects. So here the key word is well-defined. What is the meaning of well-defined? Okay, a statement should not be varied irrespective of the person, irrespective of the place, or irrespective of the thing. For example, let me give a few examples on well-defined objects. The collection of natural numbers less than 10. The collection of natural numbers less than 10. So what is the answer? We all know from 1, 2, 3 and so on 9. Right? The collection of natural numbers 1, 2, 3 and so on 3, 9. Okay? This is a well-defined collection. And which means that there are few collections which are not well-defined. Let us see what is that not well-defined things. For example, the number of talented students in our class. If I ask a question, the number of talented students in our class, is the answer unique? No. It will be vary based on the person, right? Everybody think that I am a very talented person. Some may thought that no, only few are talented. It means that the answer is varying. So here I am saying that well-defined should not be varied. It should not depend on the place or person or thing. It should not vary. Clear? Therefore, the definition of set is a collection of well-defined objects. Who has given this definition? Who has given this definition? It is George Simon Contour. George Simon Contour has given the definition of set. Set is nothing but a collection of well-defined objects. That is why we call George Simon Contour as father of sets theory. Who is the father of sets theory?
George Simon Contour.
Right. So now let us see the representation. Representation of sets. We can represent sets in two ways. We can represent sets in two ways. The first is Brewster form. Second one, Separator form. We can represent sets in two ways. One is
Brewster form.
Other is separator form. Now students, let me give you few more instructions how to write a set. Okay, what are the rules to write a set? Rule number 1, while you are writing a set, we need to represent all the elements. See here, whatever the numbers you are writing inside the brackets. Okay, those are called elements. Okay, what do you call them? Elements. So here, every element we need to write within the curly brackets. Within curly brackets. You know, there are different meanings for every bracket. Parenthesis one meaning is there, and square brackets other meaning is there. This one is the curly brackets or sometimes flower brackets also you can say. Okay. And now, while you are writing a set, the most important thing is no element should write more than once. You should not write no element more than once. Get your point? For example, when I am writing a set, I should not write 1, 1, 2, 2 like this. I should not write because here number 1 is repeated twice, 2 repeated twice. I am saying very clearly, no element should come more than once. Okay? So therefore, I have write this as 1, 2 only. Get your point?
Yes, sir.
So very important rule. While you are writing a set, no element should come more than once. Okay, that is important thing. And moreover, every element should be separated by commas. Okay, every element should be separated by commas. And I told you already, it should be represented within the curly brackets or flower brackets. Clear? And now let us see what are these rooster form and what is set builder form. First, let us see about the rooster form. The rooster form is nothing but a representation of a set along with all the elements which are there in the set itself. Okay? For example, previously in the beginning I asked you a question. The set of natural numbers less than 9. The set of natural numbers less than 9. So rooster form, how will you write that? In rooster form, for example, each set has to be represented by capital letters. Every set should be represented by capital letters only. But elements in the set are should be represented by small letters. Okay, lowercase letter. Okay, and now set A I am writing set of natural numbers less than 9. So now I am starting a flower bracket and 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is the rooster form. What I am saying here, set of natural numbers less than 9. It means that we need to list out all the natural numbers which are less than 10. Less than 10 or 1, 2, 3, 4, 5, 6, 7, 8, 9 only. If I say less than or equal to 9, I have to write till 9. Okay, your point? If I say less than 10, I have to write till 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I say less than or equal to 9, I can say this in two ways. What are those? Set of natural numbers less than 10. That only, right? Another is set of natural numbers less than or equal to 9. Both are same. Right? So therefore, in rooster form, we represent every element of the set by itself and separated by commas. And now, set builder form. This also representation of the same set, but in set builder form, we represent the set by using a statement or by using an equation. I get a point by using a statement or by using an equation. Okay, or by using condition also. So here, I can represent set A in the set builder form as, so set A is equal to, listen students, same as we need to open the curly brackets. Now, I am assuming that there is an element x. There is an element x. This element x has to follow a certain condition, a certain rule, a certain formula. Okay, what is that? Here I am saying that these are all natural numbers and less than 10. I am saying that now x is an element such that, see I can write a slash, that one here we have to write such that. Sometimes we can write such that as like this also. Okay, this always either you can write with the colons or else slash also. X such that x belong to natural numbers. X belong to natural numbers. You know natural numbers, right? Yes or no?
Yes, sir.
And the value of x is, x less than or equal, 1 is less than or equal to x and less than or equal to 9. The element x belong to natural numbers, but it should follow the rule I told you already. Okay? From where to where? From 1 to 9. Get a point? Less than or equal to x value is less than or equal to 1. So greater than or equal to 1. So it is more than 1 and less than 9 and equal to also there. Get a point? X value is greater than or equal to 1 or less than or equal to 9. This is what we have represented, the same set. Whatever we have represented in the rooster form, we are represented in the set builder form. And now we will go on to another one. Okay, types of sets. Just a moment. Now let us see types of sets. Types of sets. So based on the number of elements present in a set, you can classify the sets in different ways. Okay. The first one, if a set contains only one element, if a set contains only one element, such sets are called as singleton sets. What do you call them? Because it contains only one element, single element. So singleton set. It means that the set contains only one element. If I ask to give an example for that, singleton set. For example, a set of even prime numbers. A set of
Even prime numbers.
we all know that prime numbers are 2, 3, 5, 7, and so on and so on, right? All the prime numbers are odd numbers except 2. 2 is the only number which is even and prime. Therefore, for singleton set I told you, only one element should be there. That one is here 2. Okay. So it is set A. I am saying that it contains only 2. What is this? A set of even prime number. Since it contains only one element, we call it as singleton set. Okay. Next. Second one. Null set or void set or empty set. Listen. Here I told you that if a set contains only one element, it is a singleton set. If a set contains no elements in it, there are no elements. Okay, such set is known as empty set or void set or null set. Okay, so here empty set is represented by empty braces or else 5. Here like this also empty set is represented by empty braces or 5. You get the point? Sometimes there is a confusion. Someone is representing an empty set like this. The right is 0. Because I am saying that there are no elements in empty set, right? So here they may thought that if there is no element, so answer is 0 they may think. But 0 is also one of the element, right? Yes or no? Therefore, we should not represent an empty set, at least even by representing 0 within the brackets. We should not represent because 0 is also one of the element. Hence, empty set should not be represented like this. Clear? Empty set or void set or null set. And secondly, third one, finite set. Finite set. So here the word finite, the meaning of finite is countable. What the meaning of finite? Countable. If a set contains countable number of elements, such sets are called as finite sets. For example, I am asking a question. The number of, here I am writing, natural numbers less than 5. Natural numbers less than 5. So we can write 1, 2, 3, 4. Right? 5 should not count because I am saying that less than 5. So it's very clear, we can easily count how many there are. Natural numbers less than 5. 1, 2, 3, 4. Right? So it is a finite set. What do you call it? Finite. The meaning of finite is countable, which we can count. And now, set B and taking it, right? Now I am asking that the set of natural number. The set of natural numbers. Here I am not saying less than or greater than or something else. Set of natural numbers. So set of natural numbers are 1, 2, 3, 4, 5, and so on and so on. We are not sure what is the last element in the natural numbers. Can we say all the natural numbers there? No. Which we cannot count. Yes? So therefore, if a set contains uncountable number of elements, such sets are called as infinite sets. So here, finite is countable. Finite is countable. Next, the fourth one, infinite set. If a set contains uncountable number of elements. For example, the set of all natural numbers, the set of all whole numbers, the set of rational numbers, all this comes under infinite set because we are not sure how many there are. Got it? if I mention any condition for that, for example, here I am saying uncountable set of all natural numbers. Set of all natural numbers. Because nobody knows how many there are. If I have mentioned any condition for that, set of natural numbers less than 5, which we can easily count, right? So therefore here it is very clear, finite is countable, infinite is uncountable. Okay, next, the fifth one, joint sets. Joint sets. What is the meaning of joint sets? What is the meaning of joint sets? So if two sets are contains at least one common element, listen carefully. If two sets contain at least one element in common, such sets are called as joint sets. For example, I am taking set B here, some 2, 4, 6. Okay, I am set C, I am taking 2, 3, 5. Can I say these are joint sets?
Yes.
Obviously, because the element 2 is common in both the sets. Right? So since 2 is common in both the sets, I can say them as joint sets. Okay?
Yes.
Next, disjoint sets. Disjoint. Here opposite for joint. No element is common. Not even one. If there are no common elements between the two sets, such sets are called as disjoint sets. Get your point? If two sets are said to be disjoint, there are no common elements between them. Clear? So, for example, if I take set C is equal to A comma B comma C, okay, and set D is equal to 1 comma 2 comma 3. Now tell me, are there any common elements here?
No.
Any common elements? No. No common elements. Therefore, set C and D are called as disjoint sets. Clear? So what we have discussed till now is, so we have seen the definition of a set. Okay? The definition of a set. Who has given the definition? George, Simon, and what he has defined? Set is a collection of well-defined sets. And I have told you what are well-defined, what are not well-defined things. Okay? And later we have seen representation of a set. We can represent set, okay, in two major types. One is rooster form, other is set form. In rooster form, we can represent every element in the set by itself and separated by commas. And in rooster set form, we have to represent every element of the set by using a condition or by an equation or by a statement. Okay? And now we have seen the types of sets. In types of sets, the first one is singleton set. I told you the set contains only one element. Such sets are called as singleton sets. Okay? And the example is set of even prime numbers. Set of even prime numbers. So we all know even prime number is only one number. What is that one? 2. The number 2 is the only number which is both even and prime. Okay? And later we are seeing about disjoint sets. Null set or void set or empty set. The meaning of null or empty or void is there are no elements in the set. Not even few. Okay? Such sets are called as empty sets, null sets or void sets. Next, finite. I told you already, it's a countable number of elements. If a set contains only countable number of elements, such sets are called as finite sets. If a set contains infinite, uncountable elements, such sets are called as infinite sets. Okay? And later we are seeing about the joint sets. Joint sets are nothing but at least one common element. If a set contains at least one common element, such sets are called as joint sets. Okay? If a set contains no common elements, such sets are called as disjoint sets. Disjoint sets. Clear? Right. Once see. Thank you so much.